In continuation with the previous video, we will now look at the demonstration of the 6LoWPAN, RPL and the CoAP protocol in Contiki operating system. As discussed earlier, to run the Contiki operating system, you can actually use the instant Contiki image and download it into your VirtualBox. To run the Kuja simulator, we can go to the terminal window, and what we can do is we go to the specified path cd Contiki tools Kuja, and then we write the command and run. Now in this video, we will look at the demonstration of all the IoT protocols, and to create a new simulation in Kuja simulator, we go to file, we click on new simulation and we give it the simulation as test. We change the default name, we gave the name of the simulation as test and create. Once you click on create, the 5 by default windows of within the Kuja simulator will come up in front of you. Now in this practical, we will actually see how the 6LoWPAN border router is communicating with all the sensor nodes as well as the devices on the internet. To add a mode, run the RPL border router program, we go to modes, you will click on add mode, create a new mode, and then you can choose any mode. For this purpose, let us say we are going with the Zolertia mode again. Within the Contiki process firmware, we click on browse, and then in browse, we go to examples, and then within examples IPv6. In IPv6, we just click on RPL border router. And within this RPL border router, we select the file borderrouter.c and open. To remove all the previous object files, we just click on clean ones so that the previous object files can be removed. And once you click on clean, after that you click on compile. Once you click on compile, as previously discussed, all the C files which include the implementation of IPv6, 6LoWPAN or RPL will be compiled one by one. And once the borderrouter.c file is compiled on this type of Zolertia mode, you will have the borderrouter.co file in the end, and the create button will also become enabled. We click on create. Since there will be only one border router in our topology, the number of new modes that we are creating of this type will be just 1, and we add this mode. To actually differentiate this mode from the other modes, we click on the view option in the network window and then click on mode type. This will give it a different color, a green color, and the green area around this one mode is actually depicting its radio environment, wherein it can receive the signal strongly, and the grey region is showing where the signals will be weaker than the green region. Other modes that we want to add is, we go to modes, add modes, and then create a new mode type which would be of Z1 mode again, and then browse. Within the examples folder again, we will go to the IPv6 folder, and within IPv6 we go to the folder which is Sky Web Sense. Within Sky Web Sense we will have a file that is skywebsense.c. We click on it and click on open. Again we will click on clean just to remove the previous developments, and then we click on compile. Once you click on compile, the skywebsense.c application will be compiled on this particular mode, and then the create button will again become enabled. And let us assume we want 3 modes of such type. We change the number of modes type to 3 and click on add modes. So now as we can see, all the modes that we wanted to add have come up in a network window, right? So this one mode is running the RPL border router.c program. As we hover over it, it is running border router.c, and the 2, 3 and 4 are actually running the program skywebsense.c. Before running the simulation, let us go and see what the code has to say about these files. We go to Contiki, examples, IPv6, RPL border router. Let us first have a look at the code before actually running the simulation. So basically this is a border router, and as you can see, just like any another C file, it has certain header files, and if you closely observe, it says include net/ip/muip. This mu IP is basically micro IP, and it is the C implementation of the TCP IP stack in the Contiki operating system. As you move further, you can actually see hash include net RPL rpl.h. This is again a header file which actually gives the entire implementation of the RPL protocol within the Contiki operating system. And the rest of the program is the same as they are written in the form of a process and runs the entire C program, which shows you the implementation of the border router. Now let us have a look at the skywebsense.c file, which is again available in the IPv6 folder. When we click on skywebsense.c, the .c file is actually giving you the entire documentation, and it is basically a file which will give you the light and temperature sensor readings, and it will actually act as a demo for the implementation in Kuja simulator. And again, as you can see, there are certain header files which, of course, the Contiki.h has to be included because it is running the Contiki operating system. And since some kind of sensors are involved, we have some sht11 sensor.h file for the temperature and for the temperature readings, and the light sensor for the light readings, right? Let's go back to Kuja. Since we are connecting this, since the 2, 3 and 4 devices will be connecting to this border router, we actually want to make it internet enabled. So we go to more tools and click on serial socket server, right? We actually want to connect this one device, which is the border router, to the internet. So by this method, by the serial socket, we are actually creating a tunnel so that it can communicate with the devices on the internet. And once we have clicked on serial socket server, we click on start, right? As we click on start, it says the status changes to listening on port 6001. But right now, we are not going to start the simulation. We are actually going to create a tunnel so that we can access this one mode from our Linux system. We go back to the terminal, we click on open terminal and come out of this path and go to the path where this RPL border router file is residing, right? That is cd contiki examples. And then we have IPv6. Within IPv6, we had the option of RPL. If you are unaware of what the name of the file was, you can just type in some initials and then click on tab. Then by default, whatever the file with that name is there, it will come up. So you go to this folder, RPL border router, and then you write in the command make connect -router -kuja. And then you click on enter. It will ask you the password, and by default, as we discussed earlier, the default password for the Contiki operating system is user. You type in user, and now by this method we have actually connected the RPL border router with our Linux system, and this has actually created a tunnel with from the sensor mode to our Linux system. And now we will be actually able to access the sensor modes from our Linux operating system that we will just see right now. Now, after all these settings, we can go back to our simulation in the Kuja simulator, and from the simulation control, we can click on start. Once you click on start, as you can see, there will be some bytes which will be exchanged between the socket and the mode, right? And once you done this, and in the mode output also, all the devices will be powered up, and they will start running their by default processes, like the third, second and the fourth mode are actually running this process, that is the starting skywebsense demo, which is the skywebsense.c file that we uploaded on these 3 modes, right? Now what we want to do is we want to actually have access to the light and temperature sensor readings, which are given by this 2, 3 and 4 modes. Since these 2, 3 and 4 modes are actually transferring its data to the mode number 1, which is the RPL border router, and we have actually connected our RPL border router with our Linux system using this serial socket and connecting a tunnel from this mode number 1 to our Linux system. To actually see whether this program is running or not, we go back to the application of the internet. It could be any browser. You can use any browser. Let us say we are going to the Firefox web browser. What we have to do here is we just have to copy the IPv6 address that your RPL border router is using, you just copy this IPv6 address, you go to your browser, right, and just paste this particular address within your browser and put square brackets around it and click on enter. Once you click on enter, now what you will see in the output is, first is neighbors, right? These neighbors are 2, 3 and 4. If we go back to the simulation, pause the simulation for a while and understand, since all these modes, that is 2, 3 and 4 are in the range of 1. So all these 2, 3 and 4 are actually coming in the neighbors for mode number 1. And then these are the routes, the RPL routes, which are available from mode number 1. That is, these are the IPv6 addresses of mode number 2, 3 and 4. Let us change this configuration and bit and see whether this neighbors and routes will change accordingly. Let us say I am changing this mode number 2 a bit far away from mode number 1. Now this will actually not be in the range of mode number 1. Now all the communication from 2 to 1 will actually happen through mode number 4, right? And let us see what effect this will have on our neighbors and routes. We reload the simulation, right? But make sure once you reload the simulation, you will again have to go back to your RPL border router and then again run the make connect router kuja command, right? Once you do this, you start the simulation, right? And then again refresh the same IPv6 address, right? Now, if you observe, now currently the neighbors for mode number 1 is just mode number 3. That is, the IPv6 address of just mode number 3 is coming here. If we go on refreshing, we will see that only 3 is in the vicinity of mode number 1, and that is why in this Contiki RPL web page, we are only able to see the only mode number 3 as a neighbor for mode number 1. If we want to have an access to the readings that these sensor modes are displaying, what we have to do is we just go to mode number 3, right? Right click on it, click on more tools and then click on mode information. Mode type information will actually show you what type of mode you have used for deploying this particular simulation. Mode interface viewer. Within mode interface viewer, we will have certain options like the position, IP address, cycle clock, ID, serial port, LEDs, etc. Since we are only interested in the IP address currently, we will just take on the IP address for mode number 3, which is displayed here. That is the global IPv6 address. We want this address, so let us go back, go to a new tab, within square brackets again. If you observe carefully, the only change in the IP address compared to the IP address of mode number 1 is the last digit, right? So we just replace 1 with 3 and then we click on enter. In this way, we are through the internet, as you can see, the current readings are being displayed and it shows some reading of the light and the temperature sensor. And by using the IP address of mode number 3, the mode number 3 actually gave its light and temperature sensor readings to mode number 1. And to access that mode number 1, we have actually created a tunnel to our Linux system. And then from that web browser, we are giving the IP directly, we are giving the IP address of mode number 3. And through this, we understood that we can directly communicate with all the sensor modes, since these all modes are IPv6 enabled. They are actually running the micro IP stack within them. All these are IP enabled, and from the internet, like in this case, we have directly put in the IP of that sensor mode, and we were able to directly get the current light and temperature sensor readings. So this was an example wherein you could see how you can actually implement CoAP. As you can see, in CoAP protocol, we actually give the IP address, and then we give some methods like the get and the post method. And if we pause the simulation and I just take you back to the core folder wherein all these configuration files are residing, you go to Contiki, you go to core, net, IPv6, So in this case, as you can see, we have the implementation of the 6LoWPAN. The implementation of the 6LoWPAN is through the file sics.lopan.h. The name SICS is there because it is the Swedish Institute of Computer Science which developed the Contiki operating system initially. So this is the header file for the 6LoWPAN implementation. So viewers who are actually interested in doing some research in this area and they want to modify some parameters of the 6LoWPAN, it could be related to the header compression, it could be related to fragmentation or reassembly. So those viewers can actually go to this particular file, that is the sics.lopan.h and the sics.lopan.c, which is the header file and the C file for the 6LoWPAN implementation. For viewers who are actually interested in researching in the RPL, what you can do is you go to net, and in net you go to RPL, and in RPL we have this entire implementation of the RPL protocol, that is Contiki RPL. The entire implementation of RPL protocol as per the RFC, since we already discussed that Contiki is an RFC compliant operating system. The entire implementation is available in this only single C file, and whatever parameters you want to change, you can do that. And finally, if you go to this, if you want to perform some kind of attacks and perform some kind of security features, you go to net IPv6 and then you go to MuIP6.c. This is actually the entire MuIP TCP IP stack which is implemented in the Contiki operating system. It is basically a lightweight implementation of the entire IP protocol suite, and herein you can actually change all the variables. You can actually perform certain kind of attacks also by using this MuIP6.c. So through this practical demonstration, we were actually able to see how this 6LoWPAN, RPL and CoAP protocols are implemented in the Contiki operating systems. Thank you.